Right, students, today we will learn LU decomposition. We use this method to solve system of linear equations. Okay, how we define it? It is also called LU factorization. The matrix must be a non-singular matrix. Okay, and the LU factorization that we mean to say that A can be written as a product of a lower diagonal, a lower triangular matrix and an upper triangular matrix. So if we can write A as a product of lower triangular matrix and an upper triangular matrix, then we say that we can do the LU factorization. Okay, this is the basic definition. Now there are two types basically used in practice for LU factorization. Here you can see this is the matrix A and this is the matrix L. This is the matrix U. For L, you can see that it is lower triangular. Lower triangular means that below the diagonal we have the non-zero entries, but above the diagonal we have all zero entries. Similarly, upper triangular means that below the diagonal we have all zeros and above the diagonal we have the non-zero or other entries. Okay, so we can have zeros above the diagonal as well, but strictly speaking, we must have zeros below the diagonal for the upper triangular matrix. Okay, so now you can see here that for the lower triangular matrix, you can see 1, that is identity along the diagonal. So this is basically the Doolittle factorization when we have 1 along the diagonal of the lower triangular matrix. When we talk about the crude factorization, we have 1 along the diagonal of the upper triangular matrix, and we have other values along the diagonal of the lower triangular matrix. So this is the difference between two types. Okay. Now, when this is possible, we say A is LU decomposition. L has an LU decomposition. It turns out that this factorization is not unique. If L has 1s on its diagonal, then it is called Doolittle. If U has 1 on its diagonal, then it is called crude factorization, as I have showed you from the pictures. When U is equal to transpose of L or L is equal to U's transpose, it is called Cholesky decomposition. Okay. Now we will only go through one of these three types, okay, of LU decomposition. So let us learn the algorithm. I have made some steps for the algorithm. Please read the steps carefully and then we will understand the steps with the help of an example. LU decomposition to solve a system. You have a system AX is equal to B, okay. A is a matrix with some numbers. X is a vector. Let's say A has the order 3 cross 3. X has the order 3 cross 1. And B has the order 3 cross 1. Okay, so you have here numbers in A. X is x1, x2, x3, and B is b1, b2, b3. B's are constants and all the values in A are constants. Okay, now what will you do? You will put A is equal to LU. Okay, A, instead of A, you will substitute LU. So when we substitute here A is equal to LU, what will happen? You can write LUX is equal to B. Now put the brackets for UX. Okay, if you say that this UX is another vector Y, what will happen? You will get LY is equal to B. You can see here LY is equal to B. You will understand after some time why have we used this substitution. There is a logic behind this step. Okay, it will help us to find X. So we will solve LY is equal to B to find Y. We will solve UX is equal to Y to find X. Okay, this is the algorithm. I can ask you about this algorithm during the Viva. Okay, so please be well prepared. Now we will understand this algorithm with the help of an example. Now we have an example. This is the matrix A. This is the matrix X. This is the matrix B. Okay, and I want you to decompose this matrix A to L and U and then find x1, x2, x3 using the algorithm defined here, these 5 steps. Okay, so these are not 5 steps actually. We will solve it using 3 steps, but in this manner, okay, using this procedure. Now let us go to the first step. find L and find U. Remember that if we are saying that we have here ones along the diagonal of the lower triangular matrix, then of course we are using the Doolittle method, right? So if I have this system, this scheme in my mind, that I had a 3 cross 3 matrix here, right? So of course L and U will also have dimensions 3 cross 3, 3 cross 3. Now you can see that lower triangular matrix, above the diagonal you have the zeros, upper triangular matrix, below the diagonal you have zeros. Now how many unknowns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. To find 9 unknowns, I need 9 equations. All right. So now I know that this was my, I said that A is equal to LU. So that's why I can substitute the value of L here and the value of U here, multiply the two matrices and put it equal to A to find the values of unknowns, these 9 unknowns. And once you are done with these 9 unknowns, you have actually obtained L and U. Okay, so let us do it together. So when you multiply L with U, well, what will happen? First row, first column. 1 times U11, 0 times 0, 0 times 0. So you have U11 here. Next, you will have first row, second column. So you have U12 plus 0 plus 0. So you will have U12. Okay, similarly, let me just jump to the last step. Third row, third column. Okay, L31 U13 plus L32 U23 plus 1 times U33. So you will get this entry. Now you have 9 values here and 9 values here, and you are claiming that these two matrices are equal. Then their corresponding entries must be equal. So you have U11 is equal to 1, U12 is equal to 2, U13 is equal to 4, and similarly the last entry is equal to 13. This entry is equal to 2. Now you will solve it. How will you solve it? You will equate the similar terms, okay, according to their positions. For example, 8 is equal to L21 U12 plus U22, okay? And then step by step, you will substitute. For example, the first row is very helpful. It will give you 3 values. With the help of the 3 values, you will go to the next row and find the other values, okay? So now you can see that in this manner, we can now we can go to the third row, and with the help of the data obtained from the second row, we can find these unknowns. Notice how at each step the equation being considered has only one unknown in it and other quantities that we have already found. This pattern continues on the last row. Okay, so you can see that now if I have L31 U11 is equal to 2, I know U11 is 1, therefore I can substitute 1 here and I can obtain L31. Okay, please bring a paper and a pen and solve it with me so that you learn how to find L and U. Right, now we are done. We have obtained A is equal to LU. I will substitute L21, L31, L32 values that I have obtained during the previous step, and I will get L and U. Okay, this is the first step of LU decomposition if you want to solve a system. Now I will go to the next step. The next step is use Ly is equal to B to find Y. From where did I get this Ly is equal to B? From the algorithm slide. So this was the algorithm slide, and I said that first I will solve Ly is equal to B. So let's solve it together. Now I have L, and what is this B? B is given on the right hand side of the system. Remember this, students. Okay, so 313 4 is the B vector. Now I will substitute here. I have Ly is equal to B. L I have now obtained, okay, and Y is not known to you. You will say Y1, Y2, Y3, and B is given to you. Now you can see that first row, this column. So you will have Y1 is equal to 3. Then you will have 3Y1 plus Y2 is equal to 13. Solve it and find Y2 and so on. Okay, so you will find Y3 is equal to minus 6. All right, you are done with step 2. Let's go to step 3. Ux is equal to Y. Now you know U. How did you find U? have obtained u in step 1. So this is u124022 and 003. Substitute u here, you have x and then you have y. Okay, 3 4 minus 6. So you will solve it. All right, so ux is equal to y. You can easily solve it, students, and you can obtain x. Okay, so you can simplify it. You can see that this time if you use the last row, what will happen? 0 times x1 plus 0 times x2, 0 times x3. x3 is equal to minus 3x3 is equal to minus 6. So x3 is equal to minus 2. Okay, and then go in the backward direction, and then you will obtain x2, then you will obtain x3. Okay, so in this way you can always obtain the values of x1, x2, x3. Now at the end we have got the final solution 3 4 minus 2 as capital X. And how have you done it? You have solved a very small system here, right? So and then because it is upper triangular matrix, the solution was very easy. So you have solved it in the backward direction. 3x3 is equal to minus 6, x3 is equal to minus 2, then 2 x2 plus 2x3 is equal to 4, and you can easily obtain x2 from this equation. Okay, so now this is the homework. All right, and please upload it as soon as you do it. Okay, and grading will be based on first come first serve basis. Okay, so please solve the problem, and if you cannot understand anything, then please ask me during the discussion. Okay, thank you.